Problem 10-8. The 300 people who were lined up outside the amusement park had all entered by 8:15 a.m. By 8:30, 550 more had entered the park. The number who entered each 15 minutes increased steadily by 250 people after that. All of the people were planning to stay for the parade at noon. Must be some big parade there. That's a lot of people that are coming in. Let's check it out and see here. So letter A says how many people entered between 11:45 and noon, just in time for the parade. So the way this problem is set up here, we're talking about a parade. And these people are entering the amusement park to, early before the parade starts, which it starts at noon. So between 8 o'clock and 8:15, it says that there are 300 people entered the park. Then every 15-minute increment after that, there's an additional 250 people on top of the previous amount that entered into the park. So if we said that 300 people entered between 8 o'clock and 8:15, it means at 8:15 we've got 300 people. Now, in that time window between 8:15 and 8:30, we've got 300 more people coming in, plus a 250 more people in addition to that. So that means between 8:15 and 8:30, we're actually going to have 550 people enter the park in that 15-minute window. During that next 15-minute segment there, from 8:30 to 8:45, there's going to be 250 people more than 550 coming in. So we've got the 550 that are already coming in that next 15 minutes, plus the increase amount of 250 people, which is going to give us 800 people coming in during that 15 minutes. So there's more and more people entering in every 15-minute segment that we've got there. Again, in the next one there, we would have 1,050 people would enter the park in there. So the problem asks us how many people entered between 11:45 and noon, just in time for the parade. Well, as we look here, from 8 o'clock to noon, I've broken it down into 15-minute increments. So we've got our first increment, second, third, fourth, and if we go and we add them all up here, it'd be 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th. There's 16 15-minute increments between 8 o'clock and noon. As each progresses there's an additional 250 people coming in on top of what was already coming in every 15 minutes. So we could take this and just continue to add 250 and then list out all 16 of our different terms there from every 15-minute increment, or we can use an arithmetic sequence here to help us figure out what the 16th term is going to be. So to do that, let's look at setting up an equation. So we've got t of n. We're going to let n be the number of 15-minute increments that we've got. And then we're going to end up, t of n is going to end up equaling the number of people entering during that 15-minute interval. So as we look at it here, we're going to use the first term form the first time here, and I'll go back and show you with like the 0th term what that would look like as well. But t of n, I'm going to put my first term, which was 300, and we're adding to that 250 people each time. So our common difference there is 250. Now, because we're using that first term form, we're going to need to take this and we're going to need to multiply that 250 times the quantity of n minus 1. If you don't fully understand that, you may want to go back and check out the homework video just prior to this one there. We go through and we explain a little bit more in detail the difference between the 0th term or the slope-intercept form and the first term form. So to figure out how many people entered between 11:45 and noon, We know that's the 16th term in this sequence. We're going to go ahead and we're going to substitute in 16 for n. And then we're going to simplify. Whoops, didn't mean to do that. Let's go ahead and erase that there. So our 16th term in the sequence will end up equaling 300 plus 250 times 16 minus 1, which is going to be 15 there. So we've got 300 plus 250 times 15. And you can do this on your calculator, that's totally fine. But I'm going to do it here since I don't have a calculator up. I'm just going to do it by hand. We've got 300 plus. Now if I do 10 times 250, that would be 2,500. And then I've got 5 more, which is going to give me half of this, which should be 1,250. Like I said, if you need to use a calculator, go ahead and do it there. We're going to add all these together here. This should be 300 plus 2,500 would be what? 2,800 plus 1,250. So we should end up with the number of people entering the park here should be 4,050 people when we add those two together. So we have 4,050 people entered the park between 11:45 and noon. Sorry about the handwriting. It's tough to write on here sometimes, but we got it there. So that means there's 4,050 procrastinators there, waited to the last minute to try to get in there into the park there. Okay, so how many people are actually there? That's not a question we're answering right now. Okay, but that would, all these different amounts would be added up there to get the total number of people. We're just asked how many people are coming in right here between 11:45 and noon. Now letter B says represent the problem as a series and write a formula for the nth term. All right, so we kind of already come up with a formula for the nth term here. That would be this right here. Okay, so this is actually part of our answer for B. We'll rewrite it below. But if we're trying to represent the problem as a series, what we've got right here, right now, is if we're listing out these terms in the sequence, okay, let's talk about it here. We've got the sequence that we've come up with here is 300, 550, third term is 800, fourth term is 1,050. We got dot, dot, dot. Eventually we get all the way down to 4,050. Okay. Remember, when we're coming up with an arithmetic sequence here, they have a common difference here. Every time we increase our term by 250 there, we list it in there. So that's what the sequence looks like. If I want to write it as a series, the big difference between the two is instead of using commas here, a series, we're looking to add all the terms together. So it's 300 plus 550 plus 800 plus 1,050 plus dot, dot, dot plus 4,050. That makes sense. So if we're trying to represent something as a series, all we're doing is we're listing out the sequence, but instead of using commas, we're putting plus signs in between them because eventually we're going to get to the point where we're adding it all together. Again, if we're trying to represent the nth term using a formula, we could use this formula here, which is T of n equals 300 plus 250 times the quantity of n minus 1. Remember, this is what we call first term form. You're used to the 0th term form where we take it and we actually use like the slope-intercept there and have the y-intercept listed. What that would look like here would be t of n equals, now instead of having 300 here, we would have 50. So if you did it this way, you can check to see if this is right. And that would be, I would get 50 by distributing my 250 through the quantity and then subtracting that 250 from 300, leaving me with 50 plus 250n. This is like the 0th term form, or slope-intercept form as you most know it as. But that's all this problem is asking us for right now. So letter A and then letter B would be down here when we're looking at this part of it. Remember, this is what a sequence looks like. A series is just taking them and changing those commas to plus signs, and we're looking for the sum eventually there. All right, this is problem 10-8. Hopefully this helped you out. If you have questions still, make sure you ask your teacher. Otherwise, thanks for watching.